Continuing on with rasters, raster math and also raster Boolean operations are a whole set of functions that are really valuable that I use on a regular basis. And just going to copy and paste over some initial ones using the same paths we had before. And you'll see that what you can do with SpotPy is very easily take a raster, either a file or a data set, and add 10 to it. There's an add function that gives us a new data set that then has a new raster in it where every pixel that was in this one has the pixel value plus 10 in it. So the old pixel value plus 10 is going to be in the new one. Similarly, we can do subtraction, we can do multiply and divide. One area where this would be done is, let's say someone gave you a temperature raster where the values were in Fahrenheit and you needed to convert it to centigrade. So very quickly, you could do a little bit of arithmetic on it and convert those to different units. Okay, now sometimes you also want to find out when one raster value is, when you want to do math on two rasters. In other words, let's say you want to add the values from one raster to another. Let's say you have precipitation for 12 months of a year and you want to find the average annual precipitation. You might add up each of those monthly precipitations and then divide by 12. Or you might add them up to find the total precipitation. So a lot of times we're going to want to do that type of raster arithmetic where it's two rasters we want to operate on. Now before we do this, we have to make sure that both rasters have exactly the same number of pixels and represent the same spatial area. This resample to match function will take care of that for us. You just specify two paths or two data sets, or data set and path. You can mix and match them, and it'll give you back two new data sets, okay, that have exactly the same number of pixels vertically and horizontally and are the same spatial area and thus also the same resolution. Then you can add them together. You can also subtract one from the other, multiply and divide, all the other mathematic functions. Check the full set in the reference material. Okay, there are also Boolean functions. These are again really cool and important functions, particularly if you want to say, find out, well, where is the precipitation less than 5 millimeters of mercury in 1 month, or where the temperature is less than 5 degrees 1 month. And you can just specify a raster and then a value and say less than. And this raster will then have zeros, okay, where the pixels in this one are greater than or equal to 5, and ones where the pixels in this raster are less than 5. Same thing for greater than, and there's also a greater than or equal to and less than or equal to and an equal to function. So all of those Boolean functions are represented, and what you get back is a Boolean raster where there's zeros where this condition was false and ones where it's true. And with that, we can do Boolean operations then on those rasters that have zeros and ones in them. We'll see that in a little bit, where again you specify two rasters, it'll do an AND operation on those. So then where the pixels in this image are 1 and the pixels in this image are 1, the output pixels would be 1. Similarly, with an OR operation, then where the pixels in this raster are 1 or the pixels in this raster are 1, you will get back pixels that are 1 in this data set. Okay, so it's a spatial Boolean operation. And as an example, one more thing. Okay, so new feature, kind of cool for raster arithmetic, little shortcut. If you have data sets that are loaded into RAM, okay, you've already loaded them, you can actually just subtract one from the other, or add or divide or multiply. Okay, and this will call the same functions that are above. It's just a little bit of shorthand where you can treat these like these are scalar values, subtract one data set from the other, and then get back a new data set. Pretty cool shorthand, but either one will work. Okay, now these are all of the arithmetic functions that are represented for this shortcut. But remember, there's a whole bunch of other functions that you can see in reference, like log and exponential and things like that. So now we want to put all these together and do something interesting and applicable to natural resources, and a great example is avalanche risk. Okay, so here we're going to do slope and aspect, and here we have to specify an output path because that's just how GDAL works. Okay, and I'm going to go ahead and run that, make sure it works. And good thing to do is either do a show or go ahead and check what ends up in the file when you're done. Okay, now what I can do, and this is a really common natural resource processing step, is to go ahead and say, let's take our slope and let's find out where our slope is greater than 20 degrees. So the steeper the slope is, the greater chance that you're going to have a risk of slides, right? So this is one of the standard things we do when looking for the risk of slides. Now, I spend a lot of time in Colorado, and one of the things we do there is we spend a lot of time looking for slides on the north side of slopes, because that's where the water's retained, both with snow or avalanche slides, and also that's where they tend to happen with dirt as well, because the water builds up and stays there, especially when it freezes in the winter, and then warm spring temperatures, we can get mudslides. So we've got our slopes greater than 20, and then here we've got our aspects greater than 325 or less than 45. In this case, greater than or equal to 325 and less than or equal to 45. So pretty much north-facing slopes, okay? And then we're going to go ahead, whoops, oh, I keep scrolling like that, is then combine those together and say we want to find where aspect is greater than 325 or less than 45. We want to do it in one raster. So we can say or. So we're saying where it's greater than or equal to 325 or less than or equal to 45. And that will create a new raster that's our risk because of the aspect or the direction that the slopes are pointing. Okay, last but not least, we can create our final raster by going ahead and doing an and. So where there's a risk because of aspect and where there's a risk because of slope, that will give us our avalanche risk. And we can go ahead and save that out and show it in a window. And there's our, in this case, Mount St. Helens, where we have taken the north-facing slopes and where they're steeper and shown that these are areas for avalanche risk. And of course, this is a simple example. We could make this much more complicated by doing an index for 0 to 1 and considering the time of year and precipitation and all kinds of other factors for avalanche risk.